previous explanation, we talk about the spontaneity of the reaction, especially for delta S of the universe. So when delta S of the universe is positive, the transformation is spontaneous in the given direction at the given conditions. So now we will pass to a new function state, which is the Gibbs free energy, or the delta G. By the second law of thermodynamics, is a spontaneous reaction means delta S of the universe is positive. And delta S of the universe is equal to delta S system plus delta S surrounding. Delta S of the universe positive for spontaneous transformation means delta S system plus delta S surrounding is positive. And previously, we calculated delta S of the system and delta S of the surrounding. Delta S of the system is delta S of the reaction, for example, or delta S of the transformation. And we proved that delta S of the surrounding equal minus delta H of the reaction divided by T. So delta S system plus delta S surrounding positive is similar to delta S reaction minus delta H reaction divided by T is positive. So T delta S reaction minus T delta S reaction minus delta H reaction is positive. That means delta H of the reaction minus T delta S of the reaction is negative. Pay attention. Delta S universe positive is or has the same meaning as delta H reaction minus T delta S reaction is negative. So what is the importance of this relation? When we talk about delta S of the universe, we are interested about what's happening in the system and in the surrounding. So to study the spontaneity of the reaction according to delta S of the universe, we have to study what happens in the system and what happens in the surrounding. But by this relation, we have only the system, which is the reaction. In other words, suppose you have a reaction. This reaction has delta H of the reaction, has delta S of the reaction, and temperature of the reaction. You make the combination. Delta H reaction minus T delta S reaction. If you obtain a negative value, that means delta S of the universe is positive, so your transformation is spontaneous. So the importance, now we are working only on the system. We are not interested about the surrounding. So this combination, delta H reaction minus T delta S reaction, is called the delta G of the reaction, known as Gibbs free energy or Gibbs free enthalpy. Free energy, free enthalpy, or Gibbs free energy, or Gibbs free enthalpy. So now, instead of using delta S of the universe to predict the spontaneity, we can use delta G of the system. And delta G of the system is a combination of delta H system, delta S system, and temperature of the transformation. So for a reaction at constant temperature and the pressure, or at given temperature and the pressure, and this reaction has delta S of the reaction and delta H of the reaction, delta H of the reaction can be calculated by one of the four methods: algebraic, bond energies, enthalpy of formation, or cycle method. Delta S of the reaction is calculated from the difference between S0 of the product minus S0 of the reactant according to the stoichiometry. If we find delta H minus T delta S for this reaction negative, we can say that this reaction is spontaneous in the written direction at the given conditions of temperature and pressure. In thermodynamics, we talk about delta H, delta S, and delta G. And as I explained previously in the previous chapter, and in the first part of this chapter, that delta H and delta S depends on the pressure and the temperature. So delta H, delta S, and delta G are temperature and pressure dependent. So we write delta H, we put the pressure, and we put the temperature. And since most reactions take place at T and P constant, so we can write delta H, P, T. For example, delta H0 298 means that this reaction is realized at constant temperature 298 and constant pressure 1 bar. Pay attention how to use this relation. Delta G of the reaction is equal delta H of the reaction minus T delta S of the reaction. When using this formula, delta H, delta S, and delta G in the same formula should be at the same conditions of temperature and pressure. For example, a student can write delta G0 298 equal delta H0 298 minus 298 delta S0 298. The written of this formula is correct. Delta G, delta H, delta S are at the same temperature mentioned and the same pressure. Another student can write delta G0 500 equal delta H0 500. So the temperature should be 500, delta S0 500. Also, the written of this formula by this form is correct. A third student can write delta G at pressure 5, temperature 298 equal delta H pressure 5, 298 minus the mentioned temperature 298 times delta S at 5 bar 298. Also, the written of this formula is correct. So these three forms are correct forms of the formula. But pay attention to the conditions of your exercise. What are the conditions of temperature and the pressure in your exercise in order to use the correct form? What is the Gibbs free energy scale? For a spontaneous reaction, delta S of the universe is positive and delta G of the reaction is negative. Suppose we have a spontaneous reaction between A and B, and this reaction is spontaneous. So directly, we can say that the value of delta G at the starting of the reaction is negative. Is this value the same according to the advancement of the reaction? So when we start a reaction, delta G is negative. Delta G will increase till the value delta G equals 0. So when delta G equals 0, the reaction is at equilibrium. So what is the meaning of this scale? In other words, when a reaction spontaneously starts, it will start with a negative delta G, and that this value or this delta G will increase with time according to the advancement of the reaction to reach the maximum value for it, which is delta G equals 0. So this reaction is at equilibrium. As a conclusion, delta G is negative spontaneous. When delta G of the reaction is equal 0, the reaction is at equilibrium. When we find previously or at the starting that delta G of the reaction is positive, that means this reaction is non-spontaneous from the beginning. So pay attention that during a chemical reaction, delta G is variable from negative value to another negative value to another negative value. So delta G will increase in the negative values to reach the value delta G equals 0. And when delta G equals 0, we cannot say the reaction will stop. We say the reaction is at equilibrium. For a complete reaction, the equilibrium is the infinity time, and for incomplete reaction, the equilibrium is the time of equilibrium. Pay attention, we have two types of reactions. We have a reaction complete. That means it will proceed till the end, till T equal infinity. And we have incomplete reaction. It will proceed till the equilibrium time. And in the next chapter, in the kinetic, I will explain what is the meaning of the equilibrium. The equilibrium, at equilibrium, the reaction, the rate of the reaction in the two directions is equal. So now we have to pay attention what is the meaning of delta G 0, delta G negative, and delta G positive. Effect of T on the spontaneity. The spontaneity of the reaction depends on delta H of the system or delta H of the reaction, depends on delta S of the system, and also it depends on the temperature. So the temperature is a main factor in determining the spontaneity of the reaction. I will consider several examples. Suppose I have a reaction with a certain value of delta H, a value of delta S. I calculate delta G. From the sign of delta G, I can know if the transformation in question is spontaneous or if delta G is negative. The first example, suppose delta H negative and delta S is positive. What is the meaning delta H of the reaction negative? So this reaction is exothermic. What is the meaning of delta S of the reaction positive? That means S product is greater than S reactant, so the disorder increases during the reaction. So what is the sign of delta G? Delta G equal negative, T is positive, delta S is positive, T delta S is positive, minus T delta S is negative, and delta H is negative, so we obtain a reaction with delta G negative. So this reaction is spontaneous independent of the temperature. In other words, an exothermic reaction where during this reaction the disorder increase, this reaction is always spontaneous independent of the value of temperature. The second example, delta H is positive, so this reaction is endothermic. Delta S is negative. That means S of the products is less than S of the reactants. So the order increase. Delta S is negative times T positive, so T delta S is negative times negative, so minus T delta S is positive, and delta H is positive, so delta G is always positive, and the transformation is never spontaneous. The transformation is non-spontaneous. As a conclusion, if you have a reaction endothermic with increase of order from reactants to products, this transformation is directly non-spontaneous, independent of the value of temperature. Third example, the reaction is exothermic and the system is more ordered. So delta S negative times T positive, T delta S negative, minus T delta S is positive, and delta H is negative. So we have negative and minus T delta S is positive. Now we see the effect of the temperature. Now the temperature will determine if this transformation is spontaneous or non-spontaneous. So for exothermic reaction with increase of order, the temperature will determine if this transformation can happen or cannot. So the temperature has effect. So the temperature will determine if it's spontaneous or not. Spontaneous will be at low temperature. If the transformation is endothermic positive with increase of disorder, so delta S positive times T positive, T delta S positive, minus T delta S negative, and delta H positive, we have one value positive and other value negative. So temperature will determine the spontaneity, and in this case will be spontaneous at high temperature. As a conclusion, delta G of the reaction depend on delta H of the reaction, delta S of the reaction, and the temperature of the reaction. If the transformation is exo with increase of disorder, the transformation is always spontaneous. Endo with increase of order, directly you can put non-spontaneous. In other cases, the temperature will be the main effect. If the value of the temperature will determine if this transformation is spontaneous or not. For this reason, for some reaction, we found that this reaction is non-spontaneous at 25 degrees. If we increase the temperature to 50 degrees, we observe that this reaction becomes spontaneous. So this is the effect of the temperature. Example 6.4. Consider the reaction CCl4 gas to C solid plus Cl2 gas. Delta H of the reaction is given, and delta S of the reaction is also given, and he asked to calculate delta G. We can apply directly the relation delta G equal delta H minus T delta S. Delta G is in kilojoule. Delta S is in joule. So you have to do the conversion. You transform kilojoule to joule and you conserve delta S in joule, or vice versa. So delta G equal delta H, I transform it to joule, minus temperature times delta S. So it's equal 5.33 times 10 to the power 4 joule. Delta G of the reaction is positive. That means this reaction is non-spontaneous at the given conditions. At 25 degrees, And at the pressure mentioned, you can suppose it 1 bar or 1 atmosphere. But we say delta G is non-spontaneous without determining the conditions. But you have to pay attention in the concept that means is non-spontaneous at the given conditions in the exercise. Can we make this reaction spontaneous? Yes. How? By changing the temperature. What is the condition for this reaction to be spontaneous? Delta G of the reaction should be negative. So delta H minus T delta S should be negative. T delta S should be greater than delta H. So T should be greater than delta H divided by delta S. You have the value of delta H and you have the value of delta S. You can find the needed temperature. So the temperature should be greater than a certain value. Delta G and delta G0. Pay attention. In delta H, if a student writes delta H or delta H0, this is the same meaning. Negative, exothermic, positive, endothermic in the first law. In the second law, if a student writes delta S or delta S0, this is the same meaning. Delta S positive, disorder increase. Delta S negative, disorder decrease. But pay attention, in the written of delta G, we have a great difference in concept between delta G and delta G0. Delta G is quite different from delta G0. Suppose we start a reaction. Well, all reactants and the products are at the standard state. So we can say that this reaction at the starting is at the standard state. As soon the reaction starts, the concentration of the reactants will decrease. Those of the products will increase, so we will lose the standard state conditions. And if we lose the standard state conditions, so we cannot write delta G0, we have to write delta G. At any advancement of the reaction, there is a different value of delta G. So in the reaction, we have infinity of values of delta G. But we have one value of delta G0. So what is the meaning of delta G and delta G0? Delta G is the free enthalpy of the reaction that depends on the advancement of the reaction. You are at the beginning, in course of the reaction, or at the end. At the beginning, you have a value of delta G negative. After 1 minute, or at another advancement, you have another value of delta G negative. As the reaction proceeds, you have another value of delta G negative, but delta G increase till the end, where delta G of the reaction is equal to 0, and you say that your reaction is at equilibrium. So you have infinity of value of delta G, and when he asks to calculate delta G, he has to determine the advancement. You want to calculate delta G at what time? At what advancement of the reaction? At the starting, in course, at the middle, or at the end? What is the meaning of delta G0 of the reaction? Delta G0 of the reaction is the free enthalpy at the standard condition. So delta G0 is the standard free energy or the standard Gibbs energy. And we have one value of delta G0 is the enthalpy at the end of the reaction where there is the standard state. In other words, I start a reaction with delta G negative, so my reaction is spontaneous. The reaction proceeds, so delta G will increase in the negative value till the end. At the end, delta G of the reaction equals 0. If I am at the end and I find that the standard state is present between the reactants and the product, so at the end of the reaction, I calculate delta G 0. Suppose you reach the end and you lose the standard state. So how to calculate delta G 0? You have to do another experiment of this reaction where at the end of the reaction, you have a standard state of the reactants and standard state of the product, so you can calculate delta G 0. So delta G 0 of the reaction is identity of this reaction. But delta G of the reaction depends on the conditions. It depends on the advancement of the reaction.